Welcome to this technical deep dive into Modbus RTU and Modbus TCP IP, where we explore one protocol operating across two distinct worlds. Modbus, developed by Modicon in 1979, is an application layer messaging protocol for PLC communication. Its simplicity has made it the enduring de facto standard for industrial devices today. The core principle is a master or client requesting data or sending commands to a slave or server. Modbus resides at Layer 7, the application layer of the OSI model, defining the language of the request and response. The main difference between RTU and TCP IP lies in which lower layers they use to deliver that core message. The core message is the Protocol Data Unit, or PDU. It contains the function code, the action, and the data detailing the action. The PDU is constant. The delivery system, whether RTU or TCP, acts like the envelope and postal service. World 1 is Modbus RTU, which delivers the PDU over serial lines, primarily RS-485. It uses a master-slave architecture where only one device can transmit at a time, known as half-duplex communication. An RTU frame wraps the PDU with a slave address and a robust 2-byte cyclic redundancy checksum, or CRC. The address identifies the target device, and the CRC ensures the message arrives intact in noisy industrial environments. World 2 is Modbus TCP IP, which delivers the PDU over Ethernet. It uses a client-server architecture, supporting full duplex communication, where multiple clients can simultaneously request data from a server. A Modbus TCP IP frame replaces the CRC with a new 7-byte MBAP header. This header manages network transactions, leveraging the inherent reliability and built-in error checking of the TCP IP stack. The MBAP header includes a transaction identifier for asynchronous communication, a protocol identifier, a length field to manage data size, and a unit identifier that replaces the RTU slave address for network routing. Modbus RTU uses serial lines, typically in a multi-drop topology, and is limited to about 247 devices. Modbus TCP IP uses standard Ethernet with topologies like star or tree, offering virtually unlimited device capacity across global networks. RTU is slower, relying on serial baud rates, and uses slave IDs for addressing. TCP IP is much faster, using standard Ethernet speeds and IP addresses. TCP IP relies on its own stack for error handling, whereas RTU requires an application-level CRC. RTU's scalability is limited by its single master architecture and segment constraints, but has low initial hardware cost. TCP IP is highly scalable, supporting multiple clients and leveraging existing IT infrastructure, but has a higher initial hardware cost. RTU is inherently isolated, offering security by air gap, but lacks built-in encryption. TCP IP is more exposed to cyber threats and requires network security best practices like VPNs. However, it integrates seamlessly with modern IT systems and cloud platforms. Choose Modbus RTU for legacy equipment, small-scale, localized systems, or when low initial cost is key. Choose Modbus TCP IP for high-speed, real-time data, remote monitoring, high scalability, or integration with modern enterprise IT systems. The protocols often coexist in complex environments, bridged by Modbus gateways. Gateways translate Modbus RTU serial data for cost-effective field-level communication into Modbus TCP IP, enabling integration with the enterprise level.